Okay, super. Okay, thank you everyone for coming. I will be talking about breaking the server-client divide with Node.js and React. I dropped JS because people keep saying React rather than React.js, and that's how I'll be referring to it. A little bit about me. I've been here last year, actually. It seems to be I've been promoted because I was on Sunday and now I'm opening on Saturday, so I've done something good. My name is Dan Glozik again. I work for IBM Toronto, IBM Canada Toronto lab up there in Markham, Warden and Highway 7. I'm a full-stack architect, which is a role I invented. There's a full-stack developers, but I'm not a developer, actually. I'm an architect, and nobody complained. I even have IBM business card saying that, so they didn't also complain. Last year, I was doing something else in IBM. This year, I am in Cloud Data Services. Everything I've done last year, I'm still doing. So I'm just sort of continuing, taking all my toys and just bringing them into a different team. You can follow me on Twitter at @dglozik, and I have a blog writing about all this, and you'll see some of these ideas and a lot more if you go and visit there. So this is what my team is working on. This is just one of many sort of pages we are creating. This is an external conference. I don't want to bore you or pitch anything IBM-wise, but this is a good example, and it will help. It's good that it's a little bit out of scope, so out of focus. It's good to squint, because it doesn't matter what's on the page. Just think about the kind of a problem we had to solve. And as engineers, think about how you would render this kind of a page. There's a header up top. There's another nav on the side where you can select a bunch of pages. And then there's content. This content is kind of complex to render because there are tiles. Each tile has sort of a lot of little things that can change on their own. Users can come in and make changes to those tiles. These are all services, service instances running in the cloud. Somebody else can go in the command line and provision a service or delete a service, and now it has to disappear from the page or appear on the page. So this page is very dynamic. And in your head, if you're a React person, oh, I know how to code this. Or if you're like Angular, I know how to code this. And you're right. If you had to do this entire page, it would be fairly easy. Well, not easy. It's work, but it's doable. You can do it. Let me throw some kind of take it to the next level. We don't own the header, actually. Another team in IBM Bluemix, that's our PaaS, owns this header. So we need to somehow take that and make it part of the page that we own. But we don't know all the pages either. So the first two links on the left, it's my team, and we render it using React and Node. The analytics tab is rendered by our sort of sister team in Germany. They started with us because we taught them how to do it, and they use Node and Dust and jQuery. We since graduated to React. They didn't, so now we have diverging technology. Team in Israel, by the way, doing the exchange. They are old school. They're on Java on the server and using Angular on the client. So this page is like a Frankenstein. It's like it has to come together from multiple sources, put together. Now you think about it. You cannot just do everything in one language and one framework and be done with it. So hold that thought. We'll come back to that page. And just let's go to kind of why I'm talking about wars in general. And I'm, of course, dramatizing just for the pitch. But why do we even have these wars? How did it start? How it started? First of all, we didn't have a war. The only way to put a page on the screen was by rendering on the server. Server sent a page that was static, and that page contained links and text and images, and that was it, and nobody complained. That was, oh, look, I can navigate from a page to a page. But then we said, what if we run some code on the server? And we went into the phase of web applications. You could send a request and get back something that was different depending on who asked or what context it asked in. And then sometimes in the O's, Microsoft, they did it. They needed something special in Outlook, so they added XML HTTP requests so that they can make a request to the server, get the data without actually re-rendering the entire page. That sentence is a mouthful. So Jesse James Garrett from Adaptive Path coined something shorter called AJAX, asynchronous JavaScript and XML, which was immediately a bad name, considering that we very soon switched to JSON. And it became one of those bad decisions, like drunken tattoos or a mullet in the 80s. So, but it stuck. What it can do? AJAX is with us. And after a while, people wrote a lot of code, and realized, there's got to be at least 5 people in the world that can put together a production quality JavaScript app that doesn't suck, and it's not just a giant mass of JavaScript code. So they say, what if we take that application, take the interesting bits out, leave the skeleton, and it becomes a framework so that people with lesser abilities can come with Airware, just put that in. And we call it a framework, and that's how framework sprang up. And it was good. It was an improvement, because now you can count on smarter people than you are to kind of structure all that code for you, and you just put your stuff in. But of course, we just kept going and created monsters of pages, megabytes worth of JavaScript. So you have an situation, you click on a link, and there's a few seconds pass until all the JavaScript is downloaded and parsed, and then that code turns around, makes a request back, and fetches the data that then gets rendered. So that was the dark ages, I would say. But at that time, if you said anything about a server, they would say, no, that's like 1990s. Why would you do that? But in 2012, somebody with enough clout, Twitter, came and said, no, servers is good, guys. They were obsessed with getting tweets as fast as possible to the screen. They called it time to the first tweet. And they published a very influential article where they said, hey, guys, we redesigned our UI. We are now rendering on the server, sending the page back initially, and then, we're not going back to the dark ages. We are still loading JavaScript, but then JavaScript adds the interactivity and all the cool stuff that you so crave. But let's give browsers something to render. Browsers are amazing in rendering the sort of code, rendering HTML coming from the server. They are like in the nth incarnation. They can render that in a heartbeat. So take advantage of that. In 2013, Node became kind of fairly important. It came out earlier, but that's when people started sort of really noticing the power. And Nicholas Zakas, he's currently at Box, and he's one of the sort of famous developers, he said, you know what? This is a new way of doing things now, guys. There's no way to have this divide and have those sort of server guys and us cool client guys. Let's extend the UI to the first tier. And UUI is now the client and the first tier, that Node app that is serving. So now you can just stop being so kind of dogmatic. Do things where it makes sense. If it makes sense to do it on a server, do it there. It's just JavaScript anyway. Just decide where you run it. So take it to the next level. Airbnb said, you know what? We can do the same code on both sides. And they coined the name isomorphic. That name stuck until recently. I've heard that people are calling it now universal. I don't know what's up with that, but isomorphic, I like isomorphic. And they also created render, which is one of those horrible names with that missing letters. Render is sort of an incarnation of their idea based on Backbone, where you can run the same code on the server, on the client, and just, why not take advantage of what Node gives you? It's 2014, cutting through all the noise about Angular people who could not shut up. React appeared, and it brought in kind of a new way of thinking. If you think React is just a competitor, another religion that you can go and bow to, you're wrong. This is not an issue of what you like and what is your preference. This is a completely different way of doing things, as you will see a little later. So now in 2015, React is really hot, and everybody's sort of piling on and jumping on the bandwagon, and we are here, and we're talking about it. So I'm just going to double-click into React a little bit. I will not teach you React. Go and read. There's enough to kind of completely sort of spend the entire weekend binge reading. But just a little bit. I really like that there is a bubble gum called React, and it's sugar-free. So Even the React bubblegum is good for you. So first thing I urge people to do is not to compare React and Angular directly. Angular is a philosophy. It's a way of life. It's a civilization. React is just a library. React is just a Vue library that sort of does some cool things. In order to sort of get to the same level, you have to sort of cobble together a whole kind of stack out of a bunch of other things that you're missing, that you're getting for free in Angular, for better or for worse. So you need a router, you need to model, the model of the data, you need events, you need to sort of deliver all that. So you don't get all that out of the box. That's, I claim, a feature. But let's see. So the cool thing about React, in my view, is that it kind of focuses, because Facebook said, this is not for conferences like this one. This is not for conferences for papers people. We're running this in production. So let's focus on maintainability, on quality of code, ability of a large numbers of developers to actually do productive work and not increase bugs. We don't want to increase velocity and increase bugs by the same amount, which was the point. We want to increase velocity and keep the bugs at the same level. You should be able to look at your code and understand what it's doing. More importantly, somebody else, your colleague, should be able to inherit your code 6 months from now and not hate your guts. That's the idea. And of course, then you cannot marvel at the beauty of, look at my syntax. Look at how I sort of concatenated this string so that you need to do a triple take to understand what it does. React doesn't make you feel stupid. This line is from React 2. I'm piling on React. I'm really sorry on Angular. I'm sorry if you really like Angular. I just want to, my personal take again, your mileage may vary, is that I don't like when I look at the code and it's like, what is this code doing? I like to look and say, yeah, I see what it's doing. This is fine. And here's the thing. You may say, that's because you're stupid. That's why I don't get it. Yeah, and the jury is still out. But hear me out. We're all stupid at times of the day or the week. You could be amazing one day, you just code like a beast, and tomorrow you can have a quarrel with your spouse or your partner. You come to work, and then you're still in that, and you look at the code, you just don't get what the code is doing because your mind is elsewhere. So we should not try to pick out technology that will only allow us to be great at it if we add 100% of our abilities, and that's. I feel that React allows me to still make sense out of my code when I'm tired or cranky or anything, which happens often. So this is React in a nutshell, like a core. Something happened in my state. I better re-render. That's what it is. And it's really stupid when you think about it. It's too simple. It's simple, too simple. And it would be. If you try to do that in Backbone, for example, it would not be very you need to your view needs to be really smart, because if your model says, hey, model changed, the view said, okay, what changed? Did you add something? Did you remove something? Did some property change? Do I need to go and surgically change something? So your view has to be smart. But in React, the view doesn't have to be smart. Well, why? Well, it's because React doesn't render into a DOM. That's why. React renders into something called virtual DOM, which is just a data structure. And then React differ essentially takes that virtual DOM, compares to the real DOM, and says, OK, let's see, what changed? You added one component, one element. You removed one element. You changed two properties. I'm going to reuse that element and just sort of swap properties so that I don't have to add or remove. I'll change two properties. So that's it. The net, I'm going to change 4 properties. That's all I'm doing with the DOM. So it actually computes the minimum number of changes it needs to change, because creating JavaScript objects is very cheap. Changing DOM is expensive. That's the idea. That's the secret of why React is fast. But another important secret, not secret, everybody knows that secret. Another important property is that if you have a virtual DOM, you can write into a real DOM. But not only that, you can also do other things. You can render into a buffer. You can render into create native components. And that's why there is React server-side, there's React Native. These are now things where Angular is not going. And that's why I said don't compare them. This is a different beast. Remember how I told you that you cannot compare them directly because there are pieces that are missing. And you're right. I mentioned that state is missing, events are missing. That's because when you want to compare, create a complete system, you need something called Flux. You cannot install Flux. You can install Flux implementations. And as far as Facebook is concerned, they only have one little piece. This is Flux, the idea. First of all, you remember how we were all taught that there's this great feature in Angular called two-way binding. React, Facebook says, you know what? That's not such a great feature. Again, there's one thing of creating small apps and prototypes, another thing creating big things in production. And remember, Facebook is getting really, like, they're really betting their business on it. They're deploying, they have like 10,000 components of React in production right now and keep coming. So they said, let's see how this thing works in production when we are actually, we are really, really doing things seriously. And they realized, two-way binding causes more problems than it solves. It causes a lot of confusion. You can have a lot of contention. You can have performance side effects. So let's just dispense with it. So in Flux, there's only one flow of sort of data. And that is something happens, an action. So a user, for example, goes and clicks on a button. That's an event. That event generates an action that is sent to a dispatcher. Dispatcher is the only thing you can actually install. You could npm dispatcher from Facebook, npm install, and you get a dispatcher because it's an important piece of code, and they decided maybe they provide the implementation. Fewer people will make mistakes of translating the idea into reality. That dispatcher is, its role is to make sure that as actions arrive, they don't clobber each other, don't start fighting over views, and they are orderly dispatched into stores. Data stores is a concept that sounds like a model, but it's not. A backbone model could be a model as a resource. A backbone collection model is a collection of resources. A data store could be both. You can have singletons, you can have collections. Anything that is a state is a data store. So it's very useful. It's useful to not have to sort of go really strict on how you model your state. So when something happened, when an action arrived, dispatchers say, hey, anybody interested in this action? And sort of stores are registered and say, let me see. And yeah, I am. And then they do something in the store to react to that action. And if that changes the state, they fire an event, I changed. Another important property here is that unlike in the olden days where model views were really smart, and the model had to tell them exactly what happened. Element added, removed, some property change. Here, you don't have to. Just say something changed, and then the views say, all right, re-render. And then it lets the view figure out what actually has to change. So that's where everything is really simplified because view knows how to do things. Another very important property, an action doesn't have to be user action. It could be something programmatic happening in your app, or it could be something happening on the server. Remember that screenshot from the beginning? Somebody goes in and provisions a service that creates an event on the server. We take it, create a WebSocket event using Socket.io, great library, send it, push it to the client, catch it as an action, and dispatch it. So your action, user action, and server action, and programming actions, they all are dispatched, and they're not clobbering. Things are not sort of disappearing under me while I'm typing because a server action arrived. So this is really going to make you sure that your UI doesn't turn into this unmanageable mess that acts. One of those, the sort of bugs I really hate is bugs that happen sometime. And you could really have a hard time kind of reproducing. So far, you can say, well, OK, fine, just another way of doing things in the client. No, we'll go deeper now. So remember I told you that you need more stuff to make your entire application. First of all, there's a great piece of functionality called React Router, which is not Facebook's at all. It is an open source component. that is essentially the router currently for React, but just by the community deciding, not by somebody kind of pushing it onto us. It just became really popular. It was inspired by Ember, which happens to have an amazing router. So kudos. It just shows what we do in the community. We stand on the shoulders of those before us and just make the next step. So just sort of building up. Routing on the client is just flipping what I call fake pages. They're not real pages. Single page app just sits there in the browser. As far as browser is concerned, something happens in me. So some JavaScript activity happens. But what's really happening, just divs are being shown and hidden, and LM nodes, DOM nodes are being added and removed. That's what's happening. So React Router says, routing on the client is just showing boxes inside other boxes inside other boxes. It's the Russian doll, the Matroska kind of model. You have an A inside C inside B inside A. So if you say, here's how to get to C, here's the route, and tell it to the React Router, we'll say, fine. Next time you try to navigate to ABC, I'll show all those components the way you asked. So React Router is really great is that it uses HTML5 push state, so no more hashes. Just, that's so like O's. You don't do that. More importantly, so this is a problem if you're using like true paths, because you need to sort of negotiate with the server. If you send that to the server, server say, OK, I'll render ABC. Hey, you don't have ABC. So you have to work with the server and coordinate that. So we said, oh, we're using this as a router. Remember when I said that virtual DOM can be used to render on the server? So let's go back to that. We can render that DOM into a buffer. So we can create an express view. That's the first thing people are, oh, I can render, let me create a view. So there were already some views available very, very sort of promptly after React was available. And React Router is JavaScript. We can run it on the server too, in Node. So like, hey, what if we put those things together? If you can actually collect all those pieces, put them together, but you need that last step, that last component. And last component, as far as we are concerned, I was jumping with joy when I saw it published. It's called React Engine. React Engine is a small Node component, not Node, essentially JavaScript component. It's built by PayPal, by the PayPal engineering department. I actually know the guys who did that, and we helped them sort of tweak it and fix some of the issues. And they have a very compatible stack. We kind of grew together with them. They, together with, when they switched to Node, we switched to Node. They picked Dust.js, we picked Dust.js as well. So when they said, we're going to move to React now, they said, well, we're going to move to React. We don't want to lose. We don't want to go to single-page apps. We want to keep the ability. We like the fact that we can render Dust pages from the server. How can we keep that? So they said, let's bind React, Express, React Router. Let's use Webpack to load all that together using CommonJS. And this is what they came up with. The green part is what React Engine is doing. On the server, instead of rendering a static view, you say, this is the path, this is the view. They actually go to React Router and say, hey, React Router, do this thing you do on the client. Pick all the views you need to render for this path. But because we're on the server, the result is going to go into a buffer, not in the DOM. And then the React Engine says, thank you. Now I'm going to inject the state you used to render all that, inject into the HTML. And let's send all that to the client. On the client, sort of the client side of React Engine says, fine, let's now unpack that state that you sent me. Let's boot those React components. Let's kickstart them. And then you continue. So you render your initial content using the exact same code. You boot it on the client and then continue. So this is amazing. This allows you to use exactly the same code, and you can have your cake and eat it too. That's essentially what it is. More importantly, it's kind of, I'm happy, I feel vindicated that in the past, when people argued about why Node is so great, one of the properties was, you can run the same code on the server and the client. And it said, yeah, that's a theory. In reality, I really don't run any code. They're so different. We don't do that. That's actually not true anymore. We are running a lot of code on both. We do that by using CommonJS, by using Webpack that essentially packages chunks of the code, sends it to the client, and then we continue to require code we need. So we actually really reuse a lot. So that was all a theory. I want to show you some code now and to run something in so you can, at this point, there's a, the problem with the video is that they cannot show what we're going to show. You can follow, this is where the source code is, it's in GitHub. I'm actually also hosting this app, but I don't have Wi-Fi running here. So I'm going to show you, so let me press to run it. Yes, so the first attempt, when I saw sort of examples of what the React engine was doing, I decided, let me replicate it, create a simple app, and write about it. So this app I wrote is just an example. So let me start. You'll notice that the first thing it's doing is browsing. Oh, sorry. This is bad. I probably should. So I think I don't have time, so let me see if I can move it there. I'm going to run blind.
Command F1.
Sir?
Command F1. Have the mirror.
Thank you. That's even better. Shows you I'm a casual Mac user. I'll have to make it smaller now. Pardon me while I negotiate the sizes. So, and also a little bit here. Better. It's running on localhost 3000. So there it is. It's a very simple app. It has 3 pages. So this is all written using React. There's a little header. It has 3 links. This is just a straightforward page. So this one, I click on this, it renders a static view. React view. It uses React as an express engine. So this is kind of cool, but I could use like a dozen different engines, including Dust for this. So I click on page 2. It just, you can see how the reload, the browser jumps a little. Sort of shows that it's actually loading a full page. So this is a full page transition. I'm going to switch to React SPA. This is a single page app. At this point, the links on the left are actual React router links. And notice what happens when I click on them. Nothing. The browser is not jumping. It's because we are really rendering fake pages at this point. So we are running a React router. It is. Notice how in the address bar, these are real links. So it's showing us a real path. And more importantly, if I take this URL now and paste it into another page, notice how I arrive straight into this page, and more importantly, if I view source, look, an actual markup. It doesn't show like a little bit of markup and say, go and kickstart the SPA. It actually renders stuff on the server, but this stuff on the server, all these sort of horrible things, the data React ID that you can see inside, that's React kind of adding sort of timestamps, so not timestamp, but actual sort of revisions of those nodes so that it knows when they changed and which one changed. There's a checksum at the top. So all these things allow React to kind of take the code you render on the server, mount onto it and continue without the need to redo it over on the client. OK, so let me go into the code. So this is the code. It's fairly, it's not very complicated when you look at it. So first of all, this is sort of the main node page. First thing you'll notice is that we kind of initiate the React engine on the server. So React engine on the server is initiated. So this is where the roots are. This is how you're going to sort of configure yourself. We set the engine, which is JSX. JSX being the kind of HTML-like syntax that allows you to kind of declaratively render your views so that you don't have to go into JavaScript for that. It's not HTML, and in some cases, really not HTML. Made me kind of really mad in some instances. And also, we install a special view that is going to do that magic about sort of rendering paths as opposed to just static views. The rest is just fairly simple. We have 3 roots. Here's the root. Here's page 2. Here's your SPA. The first 2 are very simple. We just take render a view, a static view. But the third one is where the magic happens. Notice first that I instructed the view. So I instructed that all the roots that start with SPA should be sent to this guy. This is how we handle the case that we could be adding all kinds of paths on the client, and this guy handles all of them. So without this, Express will try to render each of those paths and crash, fail. Another thing is, instead of rendering this path here, this is important, instead of rendering a static view, we say render this URL. And the view we register is going to go to React routers and say, hey, guy, go find all the boxes inside boxes inside boxes, and go render that into a buffer. And then we are just going to send that on the response. So that's how it works. The rest, not very interesting. Sort of the header is a React component. It just doesn't do anything special. Pages themselves are very simple. There's a layout component that is sort of shared between them that does the actual. So this is the page with HTML and body and everything. So nothing very much out of the ordinary. But unfortunately, there is a snag. And the snag is that this was a simple example. And when we tried to do that in our actual production code, we hit a problem. So this is the page. So remember when I told you how many teams are building this and assembling this and where they are and what they're using? This is like a real-world corporation. Any team bigger than a few people in a startup is going to hit that. And if you don't hit it right away, over time you'll do. Because actually, we do it on purpose. In the past, it used to be that we build these monoliths. And we have to have this intergalactic agreement between all the teams of where we should switch. So if you have 20 people holding hands and going together, they're not going anywhere fast. We now switched to microservices based on Node.js. And with this system, one microservice can jump ahead. And that's what really happened. We jumped ahead into React. The other team stayed with Dustin. So this is a feature. But we now have to sort of do some evasive maneuvers in order to render something like this. So because not everybody uses React, we have to sort of mark some areas and say, let's pick the lowest common denominator, use that, and then do whatever you want. There's this lake in Massachusetts with completely impossible. There's like a name really, really long. In translation from Nipmuc Indians, it means you fish on your side of the lake, I fish on mine, nobody fishes in the middle. That's what the lake means. The name means. That's the first microservice architecture, I would say. So that's what we do. We fish using React and Node. They fish using Java and Angular. So this header is that middle where nobody fishes. And so how do we do that header? So the way we do this is that there are microservices responsible for serving these common areas. So the header is a microservice that you go and talk to and say, hey, I need header. Can you give me like the HTML snippet I can inline into my code? And it says, here you are. Who are you? So I give it my bearer token using auth2, and it gives me tailored content for me. Then I take the HTML and inline it into my framework's sort of way of choice, framework of choice way of inlining HTML. The same for the nav. So this content inside is React, but a header is not. So how do you do that? Obviously, on the client, that's fairly easy to do. This is where Angular way is easy. Angular has this notion of mounting inside a div. So you can create an Angular app like in the middle of your page. Then the page itself, which serves as ADV, which I coined, and it's short for Angular Delivery Vehicle. Essentially, you have this page. The team in Israel is using JSP for that, really. But JSP is delivery vehicle, and inside is Angular, and then Angular takes over. So Angular doesn't care what brought into the browser, just kicks in and runs. How do you do that on the server? Because if you are going to render start with a page and then say, hey, React, now take over, that's not the same. So this is where, let's try again. This is another example I wrote like this week is going to show how we can do it. Again, there's another repo now, and it's again hosted on Bluemix, but I'm going to run it here. Let me just go into another repo. So the same thing, I really just modified this one. We don't use browser. We started with browserify, and we had some snags, and we said, hey, oops, really? OK, it's not working for me right now. But it doesn't really matter, because the result is the same. You already seen the demo. I didn't change the end result. What is really important is the code. So how the code changed here. So you'll see the same 3 links, only that those links are now going to be rendered using Dust instead of React. So what I did here, I said, hey, we have Dust. Why don't we use that? We use Dust as a React delivery vehicle, RDV. And we'll start with React, so start with Dust, render pages. And by the way, it's actually kind of better. If you have a page that is simple, has a lot of content, React is probably not the best way to do it, because JSX is kind of a little finicky with static content. If you want to inline kind of JavaScript straight into your HTML, again, it's great for components. So when you get to build your usable components and hierarchical components, do it that. But to define the page, it's maybe better to just render it something simple. So if I go visit our page again, you'll notice this is kind of the same thing. One novelty here is that now I register another engine. I register Dust as another view engine. You can do that in Express, actually. You can have multiple view engines. Only one can be the default. But what default means is really just that you have to, the other one, you have to use the extension explicitly. You cannot just say foo. You have to have foo.dust. That's as much as you're losing. The rest is the same. Because of a little bit more code, I kind of took the controllers out into their classes, into their modules, as opposed to inlining them here. The rest is all the same. So what are those controllers doing? First, you'll notice, so this is the first page, the home page. Notice that I'm first making a request. This is the crucial difference. I'm going to make a network request. This one is really, I'm caching it. So the C request is my module. Just cache it. But all I'm doing is making another request into this microservice to fetch the header, and then take the result, which is just a snippet of HTML. I attach it to the settings, and I just pass it down to the Dust view. If you go and look at what the view is doing, the view is just going to take this common thing around and just add some content. The common, you recognize this. This is more or less the same page, only rendered in Dust. And you'll notice how here in body, the first thing I do is that I inline the header and say, take the header you got from elsewhere and just flush it here. Just inline that HTML and then proceed and just do the rest. So page 2 is doing exactly the same thing. How did the single page app change? So this is where this complex part comes. What I've done here, the beginning is the same. Let's fetch the header. Fine, we have that. Now, render React. We tell, hey, React, here's the URL. Please render it. But then we don't send it to the client. We capture the result into HTML, into the snippet, attach it to the settings, and then pass it to the dust page. In dust page is then going to declare one node in the content, this one, with the ID React mount node, and just inline what the React rendered. So that's what we are doing. We tell React, render yourself into a buffer, give me the buffer, I'll make it part of the page, and then the rest of the page is just render as all the other ones. So that's what we are doing. On the client, when you take a peek in the client, this is in the browser now. Notice at the bottom, when the DOM has loaded, what we do is we boot the client. This is this magic part where we sort of bootstrap everything. And in booting the client, we tell mount node is document get element by the React mount node. This is what you're telling it. Please mount all that stuff that we rendered on the server into this node of the DOM. And the rest is all the same. So this is how we actually are doing this in production. So let's conclude. There's no reason to have this debate anymore. My answer to server or client rendering is yes. You can have your cake and eat it too. Why is this important? Because you have instant browser content. Have you seen that wonderful article about mobile performance? I don't know who wrote it. It was sort of making the rounds. What caught my attention was this detail about how TCP/IP works on the mobile when you pull up the radio and then you start sort of exchanging package. The first packet is 14K. And then the next one is twice the size, for 28. Then the next one is bigger. The next one is bigger. That means that if you need to send like 500K of JavaScript before you see anything, how many packets of sort of exponentially increased size packets do you need in order to transfer that? You want to sort of squeeze as much as you want in this first 14K, or maybe the second, so that something comes right away to your phone. But even if you're not just targeting the phone, you want instant browser content, and then while the JavaScript is loading in the background. You get automatic SEO, you don't have to jump through the hoops to get your public page crawled by SEO, by search engines. Then what you did, all the things you put on the floor to assemble the views on the server is not lost. You just take that, send it to the client, boot, and continue. So you're getting, and you're unapologetically creating this great SPA on the server, but you don't have to pay the price for that, because you can get a head start. So there's a victory. There's no reason to fight anymore. Before we go into Q&A, I know about Meteor. And yes, they have this kind of arrangement, and it's pretty neat. The reason I think it's really important that you can do this in React is because of the community and because of the philosophical approach. Meteor is a religion. You have to convert to it. React is a library, and then all these other pieces are built by other people. So really, when you go into React, you're really buying into a community and a collection of libraries put together. So it's like investing into an index fund as opposed to one stock. Your risk is lower, because if any of those says, I'm going to, be a yoga instructor in Caribbean for a year, screw this component. Or if what Google does. Have you seen the Google graveyard of web services, where they sort of all the web services they abandoned in the past? So if they decide, we're going to abandon this library, any of the components, which, considering how much they invested, it's unlikely. If Facebook decides to just stop doing React, it's just the view part. They can contribute to the community, and somebody can take it over. But all the other pieces can continue. So it's just a matter of investment, just a matter of, it's like a community hedge more than anything. I'm sure that Meteor solution has some neat tricks in it. So thank you very much for listening. This is my handle again. This is my blog. Read it, write about these things. I'll continue. So thank you very much again.